Hello everyone, and welcome to the session about infrastructure-agnostic continuous delivery. My name is Oliver Nocon. I'm with SAP, and I have been with the company for a bit more than 20 years. I have worked in several roles, mainly in the development organization, closely with customers, focusing on web technologies and the cloud. Meanwhile, I am in a central team being responsible for the CI/CD strategy across SAP. I think there's not a lot to say about SAP. Maybe there's one or the other fun fact you will find on this slide with respect to our customers. How much chocolate they are producing, how many customers are producing beer, cars, and so on. Let's come to the topic. I guess you all know this guy. His name is Jenkins. He's been an excellent servant for many of us over the past years. Within SAP, we are also a big Jenkins shop. I guess we're one of the biggest Jenkins shops in the world. The area I'm working in, we're giving a Jenkins infrastructure to teams, individual Jenkins instances, and we serve more than 1,500, between 1,500 and 2,000 instances to our development teams. And there's more usage within the SAP. Since you know, it's a big company with more than 30,000 developers and having more than 100,000 employees. Besides technology, I don't want to bore you with a DORA report. You've seen that, right? But I just want to give you some context about what we are currently doing. In order to achieve these phenomenal numbers, is it sufficient to have technology, Jenkins or other systems? DORA says, not really, right? In essence, it's about the development culture. Having empowered teams, trunk-based development, loosely coupled architecture, which nicely supports the autonomy of teams, the autonomy of the empowered teams, high degree of test automation in order to increase your quality, and shifting left on security. Now, bringing these things together, we have Jenkins as a tool, we have development methodologies, development culture. What do we do? Within SAP, we started a inner source project, which we also open sourced in 2017, which is called Piper. What is Piper? I typically say it's shared coded or shared codified knowledge around continuous delivery. Now, what is it? We do have what we call ready-made pipelines. It's a full pipeline from code commit to deploy. Giving teams the knowledge about this flow at hand without the need to dig into that in too much detail. We see more in a few minutes. These ready-made pipelines are supported by the Piper Step library. The Piper Step library essentially performs all the integrations to the various systems which are required in your continuous delivery, continuous deployment pipeline. And we have another layer below, which is a common configuration layer. This common configuration layer enables teams to configure the steps, configure the pipelines, and so on. Now, how can you get started? First of all, the open source project provides you with a Jenkins library. Focus on Jenkins. We started with that. In order to get started, you just include the library into your Jenkins file and execute the Piper pipeline. That's it. Besides that, for a simple pull request flow, you just need to add the build tool, which might be npm. And you can see here, those are the stages your pipeline can go through. Right? For pull request voting, it will just be a simple voter build, doing some build test based on your scripts. If you merge into master trunk-based development, it will be a build, unit testing, some more UI unit testing, acceptance testing, until the artifact is promoted into product and possibly also automatically deployed into a production landscape. Now, let's focus on one key ingredient which we provide. We provide a separation of the pipeline logic and the configuration. What is provided, and that's what you just saw, is the pipeline script. The Jenkins file on team side essentially looks the same for every single repository. Every user using it just has these 2 lines of code in the Jenkins file. That has a big advantage. We do have the capability to innovate centrally. Right? You can add things to this pipeline, remove things from the pipeline, change the flow a bit, what have you. For sure within certain limits, but it gives us the flexibility centrally to influence the behavior without teams needing to know about it. And with that, reduce the cognitive load of the teams. Maybe you've read this book from Manuel Pais about team topologies, where he also digs into the topic about cognitive load of developers of teams. On the other side, autonomy and empowered teams is an essential ingredient for sure, right? How do we achieve that? We have this configuration file, common configuration layer, I just mentioned before, right? It's one configuration file, it's a YAML file, which is team owned. Therefore, they configure the bits and pieces in there for overall pipeline flow for individual stages and also for steps. In addition, they do have the capability to extend the predefined stages. They can completely override the stages, prepend, append something, all in the hands of the team. Team autonomy, empowered teams. Now let's look a little bit deeper at the common configuration layer, since I believe it's an extremely powerful mechanism. First of all, for sure, the Piper library comes with a set of defaults, some default configuration, for sure. On top, teams, companies, projects, you name it, have the possibility to add several layers even of custom defaults. That means that will be the foundation for the teams. Think about a project or product where you have several development teams working on it. You want to have some common configuration. You just put it into the custom defaults and it's out of sight of the individual development teams. If you just have one development team and you're working exactly with this team, there's not a lot of benefit in it, for sure. If you have more development teams working on something, that's where the benefit comes in. And then, again, coming back to team autonomy, empowered teams, every team has the possibility, for sure, to overwrite configuration in their pipeline-specific configuration file for stages, steps, and the general configuration. And last but not least, although not recommended, for sure, out of a Jenkins file, if you just directly consume the Piper library, it's possible to just pass the parameters to those steps. Now let me give you an example. Versioning, pretty common pattern, right? You need to do some versioning of your artifact before you deploy it or bring it to your customers. Now we do have a step in Piper. In this step, you don't need to do a lot, right? You define the build tool, then the step knows how to version this artifact, and you have some additional parameters which you do not necessarily need to do, since there's defaults. Right? The default, for example, will give you a long commit ID. You can decide to have a short commit ID, which will give you a version like that. That's pretty suitable for cloud deployment, where the version is not really visible to end users, but you need to have some kind of mean to identify what's running. On the other side, there's library use cases where you don't need this long number. You just need a somewhere version, major minor patch. You just define it as a versioning type and say versioning type is library. Then the step behaves like that. Okay, so far for Piper. Jenkins. Maybe you've seen this blog. I believe you've seen this blog from Kosuke in 2018, right? Where he wrote that he believes that Jenkins is kind of trapped in a local optimum, not really fitting to cloud native scenarios any longer. What was the result of that? CloudBees, a company where Kosuke was working for, CTO at that point in time, teamed up with Google and several other companies and formed the Continuous Delivery Foundation. That's why we're here today, right? That's why we have the CDCon. Bringing together several open source projects and several customers, supporting this foundation, and starting with projects like Jenkins, Jenkins-X, Tekton, Spinnaker, and by now also Ortelius. But there's more than what is in the Continuous Delivery Foundation, right? Most of us uses GitHub for open source projects. In there you have GitHub Actions as a runner. If you look into the different cloud providers, many of those also have some kind of runners for CI/CD scenarios. What do we do with that? In our area, and I believe it's the same for you if you're not dealing with one team only, but you have to orchestrate multiple teams, there's a question about how do we scale it? How do we scale continuous delivery across an org, right? And we basically picked this principle of paved road. Not invented by us, for sure, right? There are talks from Netflix. They're using this principle a lot as well. In the end, it's about providing some path which is suitable to a majority of teams, but not locking the teams in, but allowing them to break out, take a detour, and ideally feed things back. For sure, there might also be cases where teams break out completely and go their own path. Although we would prefer to have a detour because that brings knowledge back and everybody else can benefit from it. Now, I start with Jenkins, right? Jenkins was our initial focus. We have the ready-made pipelines, the step library, and the common configuration layer. I mentioned the infrastructure is evolving. There's GitHub Actions, there's Tekton, and there's might be whatever, right? New things coming around the corner all the time. What did we do with the open source project Piper in order to tackle these kind of topics? We essentially made Piper infrastructure agnostic. That's what I call infrastructure-agnostic continuous delivery. That means we have this common configuration layer. You see an example here for the versioning, where you define your configuration for the Piper steps. You see, for example, also a reference to Vault, which, since Vault as a secret provider, gives us also the possibility to be kind of infrastructure agnostic. We do not need to rely on the Jenkins credentials stored in a Kubernetes cluster, credentials stored in GitHub, what have you. For sure, there needs to be some reference to how to retrieve it from Vault. That will still be orchestrator dependent for sure. Now let's look at it. How does this work? Versioning example again. We have the Jenkins library. Not taking the ready-made now, just taking the artifact prepare version, which is the versioning step. We clean up the workspace, check out the repository, and do the versioning. That's how it looks in the Jenkins library. We can do it in the shell as well, right? We just need to provide the information for retrieval of the vault, for accessing Vault with a role ID, secret ID. Then we can do a git clone and just run piper artifact prepare version. It just does exactly the same, reuses the same configuration, the same YAML-based configuration. We can do that in GitHub Actions. There's a GitHub action provided by the Piper project, which allows you to do that. Also here, you just need to provide the secrets in order to access Vault, which might be required to do some Git interactions, what have you, right? Besides that, again, it's taking the checkout action and taking the Piper action and running the versioning step. We're also working on Tekton, early phases, very work in progress. Similar thing here, right? You need to provide the access credentials to Vault. We need to retrieve the Piper binary and just run it. Now, what's next? I mentioned we have the agnostic configuration layer, and we just saw how this works across the various orchestrators, right? We configure once and run it anywhere. We configure it once, use it in Jenkins, use it in a local shell, shifting left things. We use it in a GitHub action. We use it in Tekton. The power of it and the beauty of it is we can just bundle it. We can run certain things in Jenkins, other things in Tekton. This allows us to work on a migration path as well, right? Or we just use the strengths of individual systems as we want to. Just having the same configuration. Don't need to think about various scripting of the individual systems. We just configure it once and essentially run it anywhere. On top, we have the step library, right? Consuming this common configuration layer. Again, since it's implemented in a neutral way by now, not only Jenkins, there's a Jenkins wrapper for it, for the individual steps as we saw, but besides that, underneath, it's infrastructure agnostic. We can run the steps locally on Jenkins, on Tekton, on GitHub Actions, on wherever you want. Now you remember 3 ingredients, right? Common configuration layer, step library. I would check this, right? That's possible by now in an infrastructure agnostic manner. One thing we are working on, which is not really there yet, is having the agnostic ready-mades. For sure, we would wish for having the same pipeline, the same ready-made to be available in an infrastructure agnostic way on a Jenkins, on a Tekton, on GitHub Actions, on whatever, without the team having to bother about it. Reduce the cognitive load of the team. That's what we're currently working on. Maybe in half a year, I can provide you some update with that. Or you just follow our GitHub project. You find access to documentation and some more information on Project Piper.io. With that, thank you very much for joining the session again, and we have some time for Q&A. Thanks a lot, and bye-bye.
Hello, everyone. I hope you can hear me. Do you have any questions? If not, maybe you're wondering, I mentioned Tekton, I mentioned migration, and I see a question from Eric. Thanks, Eric, for your question. Hi, is Concurs also part of the tools? Since we are essentially infrastructure agnostic with Piper, it's just an executable which you can run anywhere. You can also run it on Concurs, right? If that's your CI system of choice, you can download the Piper binary, which is available via the releases of the project, on GitHub, and you can just run it on Concurs using the binary. Hope that is answering your question. Any more questions? If not, maybe, as mentioned, you're wondering about Tekton. What does the level of effort look like to write integrations? Thanks, Sean, for this question. In the end, what we try to do, and if you look into the project's development MD, we are trying to make it very easy to write a step in Piper, and with that, make it very easy to contribute. The starting point for it is essentially you write a YAML file with a step name, the step description, which parameters the step should have, and so on. If you look at it, you may find some relation to how a task in Tekton looks like. It's not 100% the same, but it looks pretty similar. Taking this YAML step definition, you just go generate. It's all written in Go. You use go generate, and the step will be essentially generated for you, the step framework. And with that, you just need to implement the real step logic. It means in the end, you get the configuration, including the whole configuration hierarchy I showed in the session for free. Inside your Go coding, you just say config dot and then the step name you define, and you can consume it and implement your step logic. We try to make it as simple as possible, and as you know, developers like documentation a lot and like to document things a lot, and not really, right? And if you start doing documentation, it's typically outdated. Therefore, what we do here is the descriptions in the step YAML will serve as input for automatic documentation generation. Therefore, we don't write additional documentation for the steps. It's all in this YAML file. Okay. Next question from Eric. Does it include built-in capabilities to configure canary deployments with metrics gathering and analysis? Not really yet. What we are looking into, what we do have though, is we have an integration for a GitOps process. That means there's a step which essentially updates the GitOps repository, and we then leave it to the respective tools here, like Argo, like Flux, in combination with Argo rollouts or Flagger, Prometheus, and so on, in order to do the deployment into a Kubernetes landscape. We try to stay out of there. We just want to create a new version of the artifact, test it, and for deploying and so on, we really try to kick off tools. There's a Kubernetes deployment step, which does a Kubernetes deployment with Helm or kubectl, but for more complex deployments, we rather look into GitOps, right? Since if you want to deploy to multi-data center, more complex deployments, you typically don't want to do it out of a single pipeline. Hope this answers the question, Eric. Any more questions? Guess we have 5 minutes left, if I see it correctly. Just looking into. Okay, let's say I want to deploy functions on both AWS and Azure. There's no direct link to function deployment yet, right? For that, essentially, Piper steps would be missing. We do have deployment steps for Cloud Foundry and for Kubernetes, but in the end, it's open. We very highly value contributions. Therefore, if there was a contribution to deploy functions into AWS, Azure, you're more than welcome to do the contribution there. Just trying to browse through the questions. I think that's all so far. Any more questions? Is integration with AppD in the near future? Planning for Terraform? AppD we don't have on the list at the moment. Terraform, we do have a step to integrate with Terraform, yes. And we're looking into Terraform for triggering infrastructure deployments, for example. And you will find a Terraform step in the documentation. Yeah, thanks, Eric. And really happy to see contributions and feedback. Always welcome. And now I'm thank you.
Hi.
Live on YouTube.
Sorry.
That happens in home office. Any more questions? Okay, then I think we have 2 minutes left. If there's no more question, maybe very briefly, I mentioned Tekton and migrations, and that we are a pretty big Jenkins shop. One thing we started, and it might be interesting for you guys as well, we started to split our Jenkins pipeline into a rather commit-based flow and a scheduled flow in order to bring the runtimes for more complex pipelines down and also increase the success rate of the individual pipelines. And for these aspects, which we rather will start rather running in a scheduled mode, we're looking into running them on Tekton, and that looks extremely prominent. Where should we run Piper? Container, function as a service, VM. In the end, it runs directly on your CI environment. And what the Piper steps typically do is, depending on the step, they will be kicked off in a container. Right? Let's assume you do a Kubernetes deployment, then you need Helm or kubectl. This wouldn't be installed on your orchestrator directly. Therefore, you would kick off a container and execute Piper in this container. And what we typically do is, like, we download the Piper binary, copy it into the runtime container, and then execute it from there. Okay. Yeah, multi-cloud deployments, exactly. I mentioned GitOps. You could possibly use Helm to some extent, but we are rather looking into GitOps approaches there. Okay, looking at the time, I think we're at the end. Thanks a lot for joining. Enjoy the rest of the CDCon, and I'm happy to receive feedback from you guys. Let me know about your feedback with respect to Piper. Just drop me a line via LinkedIn, or just write something via an issue in the repository, however you wish. Enjoy the rest of the day. Thanks for joining, and maybe I hear from one or the other one of you sometime in the future. Looking forward to it. Bye-bye.